This is a video on a hypothesis test for the difference between means. The question states, do men frequent malls less than women? 70 men and 60 women were asked how many times they went to the mall last month. The men had a mean of 2.3 times and a standard deviation of 1.5. The women's mean was 3.4. And their standard deviation was 2.8. Use alpha equals 0.05. So I have a hypothesis test because I'm asked if men frequent malls less than women. It's a yes-no question. So I need to find out what my null hypothesis is. So in particular, if men and women frequent malls the same amount, then they're equal to each other, and they means their population mean number of times they go to a mall. So I can write down H naught colon mu sub m equals mu sub w. Now for the alternative hypothesis, the key word here is less. So do men frequent malls less than women? So in particular, HA colon mu sub m is less than mu sub w. All right, now let's write down the numbers that were given and their symbols that correspond to them. Notice we had 70 men, and the men had a mean of 2.3 and a standard deviation of 1.5. So I can write n, the sample size for the men, n sub m, is equal to 70. Also, x sub m bar equals 2.3. And S sub m equals 1.5. Similarly, for the women, there were 60 women. Their mean was 3.4, and their standard deviation was 2.8. So N sub W equals 60, X bar sub W equals 3.4, and S sub W is 2.8. Now I'm ready to go to my calculator. So let's do that. Here's the calculator. I'm going to scroll down a little bit because I want a hypothesis test for the difference between two means, because I'm comparing two means. And I have statistics to work with. It's not a data set I was given statistics. Also, the men and women were not paired or anything. There's a group of men and a group of women that were asked. They're independent of each other. So I have two independent samples with statistics, because I have the statistics, the mean and the standard deviation. So I click on that. And for the first sample, which will be the men, I put in the sample size, which is 70. The sample mean is 2.3. The sample standard deviation is 1.5. For the women, that's the second sample. The sample size was 60. The sample mean was 3.4. And the sample standard deviation was 2.8. And if you remember, my hypothesis, my alternative hypothesis, was that mu sub m is less than mu sub w. So the less than is what I want. And I hit calculate. I didn't have a confidence level because this isn't a confidence interval. I could ignore the lower bound and upper bound, not about confidence intervals. But the key here is my test statistic is about negative 2.7, and the p-value is 0.00387, etc., etc. So now I can interpret all of this. Okay, here's a picture of what's going on. We have a left-tailed test because of this less than, and that means that if the test statistic is very far to the left, we're in the rejection region. We reject the null hypothesis. And if it's to the right, we fail to reject. And it turns out that negative 1.676 is approximately equal to that borderline that corresponds to a 0.05, and negative 2.73 is to the left of that. Also, the p-value, 0.004, is less than 0.05. So that means we reject the null hypothesis. And we're ready to state our conclusion. So we can conclude that there is statistically significant evidence at the 0.05 level of significance to conclude that the population mean number of times men frequent the mall is less than the population mean number of times women frequent the mall. And I'm done with the problem. Thank you for watching this video.